Okay, so today we'll just talk about the Hbase database first, and then we'll try to take a look into the installation aspects of it. Any more details on that part? So at its core, Hbase again is a ecosystem project developed in line with your Hadoop projects. On similar lines, you have all the other Hadoop and other things. Hbase also is at similar line itself. It's basically a NoSQL database, which is basically, again, you will see these days a lot of other NoSQL types of databases are available, like DynamoDB or Cassandra and other stuff. Google has its own NoSQL type of database, as well as Oracle NoSQL database also is a prominent one. So basically that's a different stream itself. Hbase has or used in that particular sense. It's a key value type of storage database, which is different from traditional model. So let's talk about some of those things. So at its core, Hbase is a open source distributed sorted map modeled or database based after Google's big table. So Google published this big table paper, the research paper. We have seen the earlier versions of it, your map reduce as well as your other HDFS file system. Hbase is also based on similar concept which they published. That was their big table paper itself. You can see that it's again open source in the sense that Apache maintains the detail for it, and a lot of different companies and contributors are it for the development part. Now to do the installation and all, it's exactly, or it's very much similar to the way you will do it for any, or the way we have been doing it for other ecosystem projects. You will do the same for this as well also. No specific differences in that regard. You'll download the binaries, modify because it's a database, so it requires a directory and all to be located and updated for. So we'll have to specify the same thing in the Hadoop, this one conf/hbase-site.xml. This is the place where you will mention or specify the root directory or the temporary directory where it will store the database tables and all. As well as Hbase, just know that it also requires another component from a process management perspective called Zookeeper that needs to be configured. So you will configure the property Hbase Zookeeper related property to point to your Zookeeper directory. When you download Hbase, you will see that you will have a Zookeeper version coming in inbuilt. So you will have the Zookeeper jars coming in. In the Hive example, you guys did saw that Zookeeper was there, and that was because Hive has support for this particular stuff. So since the distribution of Hive wants to support Hbase, it comes with both Hbase and Zookeeper. Standalone also, you will have to have Hbase and Zookeeper thing configured. Something you will be doing in, and again, startup and all will be, as we will see, will be in line with what you do at the Hbase level, the Hadoop level. Go into the bin and start the Hbase shell. It will just open a prompt. It will start the Hbase shell, which you can use to create tables and add data. Now, the difference we'll see later on in between Hbase and Hive is that Hive acts as a more kind of a front end or a warehousing tool, which gives you HiveQL to play with the data that is stored either on your HDFS or local and all. Hbase does not gives you any such query language and all. It's primarily to store large amount of data. You can integrate Hbase to Hive so that Hive query languages can take this data in HBase and use the intelligence. So these are two different things, not one and the same thing, if that question is coming into the considerations. These are two different things that needs to be explored parallelly, and they do coexist. Now again, this has been developed primarily as an alternative to or based on the typical relational database models that we have. But with the typical relational models, we do have certain challenges, although they are good in terms of the existing capabilities that we needed so far in terms of processing and all. With the growing need for data and all, they've not been able to cope up that well. So that's where the distinction happens. And the hardware that you need, like mostly you are stuck to some vendor or something where you have that dependency coming in, so that is also there. Of course, the cost and all other reasons are also the same thing. So you will see that primarily it's the limitation we have in terms of their architecture to deal with this much big amount of data, so they can efficiently use that and get that detail out. Hbase, and for that matter the entire NoSQL type of databases, as an alternative to store large amount of data in a more efficient manner. You will not get all the functionalities which you get in a typical RDBMS, transaction handling and other thing, but at least you will be able to store the data and access it randomly. So the key part of that particular thing is done. So that's something which you will be seeing in here. The background, if you will see, started from the big table paper which got published. First time in 2007 it came in, and again now it's a pretty much, I will say, a supported project there, comprehensive project which has come up. It just gives a high level introduction or detail on that particular part. It's a part of your Hadoop ecosystem, and like Hadoop, it is also an open source thing itself, and both of them are written in Java. We have seen that Apache Peg, Apache Streaming API, Hive, all of them are written in Java. So the entire Hadoop model has been around that particular part to write things in a distributed manner, as well as also use Java as a standard choice to look into the details and all. So that's something which they have been following in directly. Hadoop by its own capability has this fault tolerance and scalability, and that's where Hbase and all this tries to leverage those capabilities and all. These are just some high level advantages which it's trying to tell about the Hadoop. We have already gone through it. It's the range of data that it tries to operate and all that particular part. MapReduce and SDFS, we have seen the two major components and how they are used in detail. Alright, this is an important distinction that it does between HDFS base Hadoop, because that is also used for storage, as well as your Hbase. Again, this is just a typo here, but Hbase is at a Google file system level, so the internal storage that it will do will be mostly key value pair, and in a while we'll see that architecture. HDFS and all will try to get that detail in a more distributed manner, and it will directly write it into that text file or whatever that format and all that comes in. Hbase, in that core, it can use your distribution of HDFS for its storage, so it can store the data there as well as locally also it can store, so that you use it in a comprehensive manner. Apart from the traditional RDBMS type of approach, this is a column oriented database. So once you will try to explore the non-SQL or NoSQL databases, you will see you will have lot of different options by way of that. You guys can do that. And Hbase is a specific non-column oriented database. You also have the DynamoDB and all from Amazon and Cassandra. They have different models that's available. And we'll see that how you can make it multi-dimensional and storage system and all those type of things. They all are available there. Important point to note here is that Hbase is not a SQL database, so you will not have many of the low level things which you typically see. Joins and all those type of things will not be there. Any internal query engine, as we talked about, that's not available here. And you will not be able to see the typical schema and the DBA type of work needs that we have. So you will not find those details coming in. The storage model which Hbase uses is a column oriented stuff. So each of the rows and all, they also will be stored in a column itself, and you will see we will have a sample structure of how that looks like. And as it said, these are just some silent level features of it. Hbase, again, if you are more into or have a challenge of storing large amount of data, you can get that thing. But Hive and all are more comprehensive MapReduce framework type of thing. Hbase only help will be to have a random access and all, because it's storing it in a key value manner. You can randomly access and get into the low level details. That will be something where it helps out to get the data. HDFS, if you are having your data there, is mostly a sequential access type of data, but it is this Hbase which gives you the, or which gives the ability for column type of thing. This is how your static columns or traditional RDBMS has the details. If you look for something different in terms of the storage and all, this is how your Hbase and all will try to approach this solution, wherein they store even the rows also in a key value pair manner. So you can see that if you have Hbase base data, this is where it is trying to store. One row is occupying multiple. You can see the only difference or considerable difference is the way it is storing the rows. So you can see that the row key 111 and each of the columns are separated, so you are not actually extending it in a horizontal manner enough. So at any point of time you will have key value which you can associate. So just to get single row details, you will access in this particular table all these three individual rows. So to get one record, you will get the name you can get from the first row, age and sex. This is three different attributes. Same way for all others also it will come. So it's a key value type of storage rather than in one record stored in one horizontal components with one primary key. So the primary key or thing will be there, but it will have multiple occurrences for each of the column. Here are some other examples of row as well as the type of value, that not only you should be storing just a single value, you can store a set or a map also corresponding to that. So instead of this cutting and all, you can see that info and roles are composite data set, but you will be able to store them and you will be able to access them in a group manner. That's what it will try to do. Whenever you will search for cutting as a row key, the entire text will come, which is in the data section. Column families level, because it's a column oriented database rather than a row specific thing, you can have some of these details. So you can see that since the different columns that it stores, different set of columns may have different priorities in terms of how the access of data that you want to do, because the timestamp and other related details may not be very relevant and used frequently. So you might just go for the actual value part and the other ones will say. Again, this is something where you will have to start having a good understanding of NoSQL databases. Hbase, since it comes in a bigger bundle of Hadoop, is there discussed. We will install it and we'll just do some small configuration, but understanding the nitty-gritties of Hbase, might as well want to first understand the the NoSQL concept. That's something which will be helpful. So column families, see, they're stored separately on disk access, one without wasting the IO on the other. So it's not something which are like stored in a parallel manner, so that if if you are accessing one particular row, since all of that, so again basically there is no locking concept, row level locking and all, because they are stored in different formats, and each of the column itself are stored differently. So for one column at any point of time you might be looking for just the name. So if I have a person, say his ID is 101, and he has his name and age as well as the department, all these things, name column, age column and department column, will be stored differently. So if someone is accessing the name, you can still access the department and the age part. That is a different approach there it goes. A lot of things which you can specify at the configuration column family level. You can compress the data, of course. That's a need which we have seen in Hadoop also earlier. You can always compress the data. That way it will be more efficient to store the or utilize the overall space available. This is a high level comparison and an important comparison actually from Hbase and RDBMS perspective. If you look into the basic layouts of the data that they have, RDBMS, your traditional ones are row oriented, each record in a full row, but Hbase, as we saw earlier, the format is all column oriented. Even the details of one record are in different columns. The query language you can see is SQL, which is a more defined one. At Hbase level you have basic commands like get, put, scan. So get is like to see what's up or have the data in, put is to put it inside, scan is just to take a look at the current but it's nowhere comparable, or you can't fire complex queries and all that thing. It's just minimum basic get and put type of thing, so that you can see the data which is there and you can put the data in. Security, again, those are certain things which at Hbase level you might not find it very elegant. As we talked about this, the purpose there is to store large amount of data, and it comes with many compromises on security, transaction handling, concurrency support, all that thing. It's the size factor which makes the big things, that petabytes, and as it can say, hundreds of petabytes can be stored. And when you want to read concurrent read and writes, you can do millions of queries per second. So that's where the inspiration is, that have the storage of data in a more efficient manner, so that your read and write becomes efficient, and then use your Hive query and other thing to make things more, I'll say, faster, because Hive gives you stronger Hive QL which can get that detail. These are certain terminologies which are used in Hbase concept. You have a reason, which is basically a subset of table rows. region server, which basically serves data for reads and write whenever you fire a query to basically get, put or scan these type of queries. It gives you the data. And then you again also have a master which deals with all this contribution or communication with the slaves and all those things. So again in Hbase also, it's not just that it will just store it on one particular disk, it stores it across multiple disks, and that's where the master and the slave help out in terms of giving you the data in a faster manner. Hbase can be considered to be a parallel for HDFS, but in HDFS you do store it in a very core form like text form, binary form. Hbase, it will always result or boil down to a NoSQL type of form. So all the communication that happens between the master and the slave regions is done through Zookeeper. Try to explore more on the Apache Zookeeper API. That is a separate project which is available by Apache. Internally, your Hadoop also has been built or has been inspired from many of its concepts in terms of the process communication between which happens between name node and data node and all that part. So that is primarily for all that type of distributed process communication. From an architecture perspective, this is a more, I'll say, comprehensive architecture. You can look at, just let me have a, it's now in between storage, but you can see at a very high level. Let me enlarge it and we'll then navigate around. At the top level, you'll still have the client part and the HMaster part and the individual data stored in the server regions, which is called as region servers, which are available. Internally, it gives you some other more details like logging through the hlog component. H file is where the individual data is getting stored and how it's trying to store the data on the data nodes at the Hadoop level. So that whole level is abstracted from you. Internally, it does all that coordination because it tries to utilize the space which your Hadoop data nodes are providing, but the mechanism or the format in which it is storing is different from the core HDFS format. This is where the distinction comes in. This is a good high level architecture for a Hbase type of data or a distributed interaction. The role of Zookeeper is at the top, wherein it's doing basically the process communication with the master and the client and also the nodes and all. You can interact to Hbase using Java. You'll see that I will be sending you some exercises for Java based interaction similar to that for the normal HDFS we have done. Add the jar file, use either Eclipse or any Java IDE, add the jar file and then try to use the APIs to create an interaction. And at Hbase level, since it's a database, all you will be interested to do is create tables as well as access the data that is there. So Java is available definitely. Thrift server, that is something which we did talked about in Hive. That's a component which is available, or a server capability. Hbase shell of course will be the default one that will be available. These are the key APIs that it offers. The get call, put call, scan call, increment call, as well as check and other things. You can delete it also. You can actually disable a database also there, so that it becomes a non-readable. It will not delete it, but it will disable it and all. And you don't see there is any comprehensive support for any query and all, because database, or at least Hbase, is for mostly storage. So typical get and put type of thing which are available, not the low level query related APIs and complexity around that one. There is no query engine built in there. These are some simple commands which you will fire once you have a Hbase shell up and running. The first one you will see is to create a Hbase table with test and CF as the two columns. You use put to add value into it. See, it's a simple put. You're putting in the test, you specify that I want row 1 as the data, and the next one you're providing the value, some other row. So this is a typical syntax in which you will be putting in no like insert into table, that type of thing. So Hbase, as the name suggests, is Hadoop database. That's what it's sold and utilized. But you will have to come out of your conventional boundaries of DBMS type of databases to treat it in a different manner. You just want to, after just creating the table and adding some data, this is a NoSQL type of thing. So any other NoSQL database also you will access, you will find very close similarity in terms of the access. You can see the scan command is something which you use to just take a look at the data that is available in the whole table itself. Then it shows you that although you added, just you can see here that it does adds the timestamp also for each row insertion and all. That's something which is a helpful attribute. Command wise, it's not very comprehensive or very much complicated in terms of like the way you have Hive and all. You have to learn a whole Hive QL and all. Hbase is simple storage, so get, put, scan, these things should be sufficient. In commercial purposes, at least the simple implementation which I have seen in the past getting done is to use it in line with Hbase, sorry, in line with Hive, and have Hive offer a Hive QL type of API to refer to this data and offer you it in that particular manner. Yeah, this is just a good example of how you will do the same in Java. You can see the configuration and all API is very similar to the way we have used the HDFS Java part. We are using, instead of a normal configuration which you created in HDFS, sorry, we are using or creating a Hbase configuration now, and to that you are providing the location of your Hbase site.xml. Once you get that conf object configuration, simply use the htable command. That's another wrapper API written for the Java folks to consider Hbase base table as htable. Specify the conf and refer to the table name, and you configure it here whether you want to do a single update or a batch update into that table. You will accordingly add the data. So here in this example it's using batch update. So it first creates a batch update for the visual row, and then it is putting multiple values. So as you can see, both your Hive-based thing or access is the most common at Hbase level. Directly also you can interface with the cell, but it's of no direct practical commercial uses. As a database, you can have a integration with Java, and that could also be a more useful thing. So Hive as well as Java based interaction is a more commercial usage for Hbase compared to the normal shell that it offers. So it depends on the different role. Like if you are in an application development part, you might want to have the Java and all API explored, because that's where the developer focus will be more to integrate and do that stuff. Admins and all will have a more focus on the shell based things. Hbase is not very complicated like other products, Hive and all, so just have a simple setup. NoSQLs are written for that, another reason, that to make it simple, not unnecessarily make it complicated. The RDBMS and all that we have these days are quite complex and all, not very easy learning. Hbase in that sense is far easy enough, since it's on a NoSQL type of thing, so a lot of those initial traditional things are not applied anyway. This is just now mentioning more into the details of from a Java perspective or a programming perspective. That one. If you want to get a particular row, you will configure the same here. We did saw the get command at the shell level. This one is just a replication of the same through a Java API. Now again, internally I'll share with you guys a case study. Hbase is very, I'll say, Facebook definitely is a known user of it in terms of its whole messaging thing. So messaging and all that we do, Facebook messaging and all, storing messages and retrieving it in real time is something which tries to do. And they have a good case study wherein they have mentioned that what all they have tried and how Hbase helps from their traditional approaches of storing it on MySQL or even Cassandra and other NoSQLs. How Hbase has helped them out. It's available openly also. You can download it. I'll be also sharing with you as needed. But real-time usage again will depend whether you have that much of type of volume or if you are really facing a good latency with your existing RDBMS solutions. These are certain key guidelines factors which can be kept in mind while making a decision to use Hbase. The most important feature that it offers is the random write and read capability. So if you need either of it or both, then Hbase could be your potential choice. You have a volume like in terabytes and in petabytes where you have to do the operations of insert, delete, add, update. Hbase will be a helpful thing. And your access patterns are simple. So this is important in the sense that when you are trying to access your data, it's not very complicated query with multiple where clauses, group by, order by, subqueries, joins. If that is the level of difficulty, Hbase might not be able to help you out because the storage wise, if it starts trying to group all that thing, first of all, it does not gives you any query language. So even if you built it on top of Hive, so that you use the Hive query language as an option and Hbase as a storage, you will still not get a very optimal performance. So you have to take a good use case of, just because you are using Hive to create a query in a easier manner does not makes a specific implementation as a viable case for or a more optimum case for Hbase usage. Hbase should primarily be used for large data storage and operations, and when you have to read frequently reading and writing things. So mostly the search companies which has to do that, messaging companies which has to store that, telephone companies, telecommunication companies may have this need. Billions of call data stored, basic identity and all, and that needs to be stored fast as well as retrieve also very fast. So those are the places where you might have a consideration for Hbase as a viable business scenario. Yep. I think that's it. Not much to thank you on that part. So next we'll go ahead and start up the installation for Hbase. We'll download it from Apache as we have done it for previous components, and we'll just do a small setup to make it running. Thank you for the session today.